Let's start our discussion now. Juvency.
Yes, we can start. I'm ready.
Okay, so our last topic was, I think, root summarization, I think.
Yes,
So we complete our RIP and EIGRP summarization, right?
yes.
Okay, now let's focus on protocols now, okay? And today we are trying to start our OSPF protocol first. Let's start our discussion with OSPF, and this protocol will take minimum five to 6 sessions. Juvency, okay?
Okay, no problem.
So our first dynamic routing protocol is OSPF, Open Shortest Path First. It's a full form of OSPF protocol. Let's talk about some feature. Let's talk about some feature about OSPF protocol. So OSPF is a link state routing protocol. OSPF is a link state routing protocol. If you talk about RIP protocol, RIP is Open Standard Protocol. OSPF is also an open standard protocol. OSPF is a link state routing protocol, but RIP is called distance vector routing protocol. Distance vector. What is distance vector means? Any idea what is distance vector? What is distance vector routing protocol? For example, I have R1 router and R2 router. If I'm using any distance vector routing protocol in between R1 and R2, for example, RIP protocol I'm using. So the problem with the distance vector routing protocol is they send routing updates. They will send update after every 30 seconds. Okay. They will not send incremental update. I'm talking about distance vector routing protocol, RIP. They will not send incremental update. They will always send periodically update. For example, R1 will share his routing table information with R2. Now, after 30 seconds, again R1 is sharing his routing information with R2. Again, after 30 seconds, R1 is sharing his routing table information with R2. This is the
Okay.
problem. This is the problem with the distance vector routing protocol. They send routing update periodically. But if you talk about OSPF protocol, OSPF is a link state routing protocol. It means it always send incremental updates. Whenever any change happen, then one router will share his update to another router. Clear my point? So OSPF is a
Yes.
state routing protocol. It's a open standard protocol, so we can use on any vendor like Cisco, Juniper, Alcatel, any vendor. OSPF is using SPF algorithm, shortest path first, or DJ Castra algorithm. If you talk about RIP protocol, if you remember from CCNA training, RIP is using Bellman-Ford algorithm, right?
Yes.
RIP is using what? Bellman-Ford algorithm to find the best route. Bellman-Ford. If you talk about EIGRP protocol, EIGRP is using dual algorithm. Dual algorithm to find
Mm,
the best route. What is dual algorithm? Diffusion update algorithm. RIP using Bellman-Ford, but OSPF is using SPF algorithm, shortest path first, or you can say DJ Castra algorithm. It's a classless routing protocol. OSPF is a classless routing protocol. Yeah, GRP is also a classless routing protocol. RIP version 2 is also classless routing protocol. What is classless means? It support FLSM, VLSM, CIDR. So it support FLSM, VLSM, and CIDR, and it support manual summarization only. If you remember root
okay.
summarization
Yeah.
concept, remember
So
root
totally
summarization
got it.
concept. RIP and EIGRP, they do auto summarization. But in
Auto summarizer.
you need manual summation. UNC, right?
Yes, yes, I
Now,
remember.
yes, let's talk about other points. So OSPF sends incremental updates. Incremental update means what? Whenever change happen, then R1, for example, we have R1 router and R2 router. Now, OSPF send incremental updates always. For example, R1 will exchange his routing table information with R2. Now, when there is a change, for example, one network here down, one network is down, or one network is up. Whenever any change happen, then R1 will update this information to R2. So it sends always incremental update, not periodically update. Now, hello timer, OSP of hello timer is 10 second. So after every 10 second, R1 will send a hello packet information to R2. Only hello packet, not routing information, hello packet. You can say keep alive message. R1 is sending hello packet to R2. R2 is sending hello packet to R1. And hello packet timer is what? 10 seconds. So after every 10 seconds, they are exchanging hello packet information. Now, what is dead interval? What is dead interval? So for example, R1 is not available. R1 is down, for example, and R2 is not receiving any hello packet. So one hello packet timer is what? UNC.
10
10 seconds.
seconds.
So if one
Yes.
first hello packet is miss, okay, first hello packet is not coming from R1 because R1 is not available. So now R2 will wait. In this case, R2 will wait for three hello packet more. It will wait for three hello packet. One hello packet timer is 10 seconds. Three
10
hello packet
seconds.
timer is what? 30 seconds. So
30 seconds.
first hello packet is miss. Now R2 will wait for 30 hello packets. So total it will wait for 40 seconds.
40.
In 40 seconds, if R1 available, if R1 is available, good. If R1 is not available, then R2 will remove or flush R1 information from his routing table. R2 will flush the root information about R1 from his routing table. Now in new routing table, R2 don't have R1 root information. So now in next hello packet, R2 is sending root information to R3. And in new updates, R1 information is not available. Clear my point? So dead interval is what? 40 seconds. OSPF updates are sent as a multicast address. And OSPF is using two multicast address 224.0.0.5, 224.0.0.6. So OSPF is using two multicast address. If you talk about a RIP protocol, RIP is using one multicast address. If you talk about EIGRP, EIGRP is using multicast address. RIP EIGRP is using 224.0.0.10 and RIP is using what? 224.0.0.9. And so RIP and EIGRP, they use single multicast address. But OSPF is using two multicast address, 224.0.0.5, 224.0.0.6. So where you can use 224.0.0.5 and where we can use .6, we'll discuss, okay? But right now, I'm giving you an idea. We have two multicast address in OSPF protocol. Clear my point? Do you see?
Okay. Yeah.
OSPF metric calculation. OSPF works with bandwidth. EIGRP works with bandwidth. OSPF works with bandwidth. High bandwidth, least cost. Least cost, best route. OSPF administrative distance is 110. If you talk about static routing AD value, 1. RIP AD value, 120. EIGRP AD value, 90. OSPF AD value is 110. Now OSPF, see, OSPF, RIP protocol, EIGRP protocol, and OSPF protocol, they support equal cost load balancing technique. They support equal cost load balancing. What is equal cost load balancing? For example, I have a R1 router, R2 router, R3 router, R4 router. Now, if I'm using, for example, RIP protocol, so RIP always works with hop count. RIP can't understand bandwidth. RIP always works with hop count. So if here is a source, and this side we have a destination. So from this source to this destination to reach, from this source to this destination, we have two routes. You can go via R2 or you can go via, so you have two routes. Now you can see via R2. Via R2, you have two hop count, 1 and 2. You have two hop count. And via R3, you have two hop count. So to reach this particular destination, you have multiple routes. You have multiple routes with same hop count, with same metric, So what router will do? R1 will install both the routes in routing table, and it will utilize both the routes. Clear my point, UNC? This is
Yes.
called equal cost load balancing. To reach
Cost to
any
root.
yes, UNC.
You say cost to root balancing, right?
Yes. To reach any destination, if you have
English.
multiple routes with same metric, then router will install all the routes into the routing table, and it will always do load balancing. And what it's called? It's called equal cost load balancing. So RIP, EIGRP, OSPF protocol, they support equal cost load balancing. But if you talk about EIGRP protocol, so EIGRP can support equal cost load balancing and unequal cost load balancing. Yes, in EIGRP, we have a great feature, unequal cost load balancing. So equal cost load balancing and unequal, both options we can use in EIGRP protocol. But if you talk about RIP protocol, RIP, OSPF, EIGRP, they only support RIP or OSPF, they only support equal cost load balancing. Clear now this point?
Okay.
Now, OSPF is using area concept. Remember from CCNA training? OSPF is using what? Area concept. You can put all your devices in OSPF area. Let me tell you. Let me create a design first. Okay.
Okay.
So in OSPF, we have area concept. All the routers we can put in an area. Okay. These are routers. Okay. Not desktop machine. These are routers. Now in OSPF, we have area concept. And here we can create area 0 first. In OSPF, what we have area concept. So you can create area here. You can put all your devices in area. What is area? UNC. What is area? Remember from CCNA training, it's a logical grouping of routers, right?
Yes.
It's a logical grouping of routers. So in OSPF, we can create area here. And as per rule, as per default concept, you will create area 0 first. Wait. Area 0 first. Okay, so this is R1, this is R2, this is R3, R4. So as per rule, you need to create area 0 first. So what I'm doing, I'm trying to put all the devices. You need to create area 0 first. Why area 0? Because area 0 is called backbone area, right? Area 0 is called what? Backbone area, or you can say transit
Backbone.
area. You can say transit area. So what I'm doing, I'm trying to put all the devices in a single area. Okay, I'm not creating multiple area here. Yes, you can create multiple area. So, but first you need to create area 0 first, because area 0 is mandatory. Area 0 is called backbone area or transit area. So what I'm doing as a network admin, I'm trying to put all my devices in area 0. If I'm putting all my devices in a single area, in area 0, for example, I have I have 200 routers, and I'm putting all the devices, all the routers in a single area, area 0. Now, what will happen if I'm putting all the devices in a single area? So if anything happened into this area, for example, network goes down, for example, this router is not working, this network goes down. If anything happened into this area, it will disturb all the routers. This update will disturb all the routers within an area. And now into this design, I'm not using high-end routers. All the routers are not high-end routers. No. Into this design, I have some access layer router. You can say entry-level routers. I have some mid-range kind of routers. I have high-end appliance. I'm not using all the devices are not high-end appliance. Okay. Into this design, I have some entry-level routers. I have some mid-range routers. I have some high-end appliance. So entry-level routers, they have limited resources, hardware resources. If I'm putting all my devices in a single area, so this update will disturb to all the routers. High-end routers will receive these updates. They can handle no problem. But what about entry-level route? They have limited buffer size. They have limited hardware resources. So maybe they cannot maintain these updates. Clear my point?
Yes.
So that's why we are not putting, my point is we are not putting all the devices in a single area. No, that's why. That's why we are not putting all the devices in a single area. What we can do, we can create multiple area here. We can create multiple area, but the rule is you need to create area 0 first. So what I'm doing, I'm trying to create area 0. So these routers I'm putting in area 0. So first you need to
Okay.
create area 0.
Okay.
Now second, if you are creating other areas, for example, I'm creating area 20. These routers I'm putting in an area 20. So yes, you can create multiple area, no problem. You can create multiple area. For example, this is area 30. This is area 40. Yes, you can create multiple area, but the rule is all the area must be directly connected with the areas in UNC.
Okay.
So I'm creating multiple area, 10, 20, 30, for example, 20, 30, 40 area. But you can see into this design, all the area all the area are directly connected. They are directly connected with the area 0. See,
Zero.
area 20
Okay.
is connected with area 0. Area 30 is connected with the area 0. Area 40 is connected with the area 0. And this
Okay.
router, this R2, wait, this R2, this R3, and R4. These routers are called ABR router in OSPF. These are called ABR router, area border route. Area border route. R2, R3, R4, they are called area border router. Why? Because his one interface is a part of area 0, and other interfaces, they are the part of any other area. So this router is called what? ABR, area border
Yeah.
router. This area border router can send area 20 updates to area 0, area 0 update to area 20. Now same, we have R3. R3 is a ABR router. R3 is a ABR router, area border router, because his one interface is a part of area 0 and other interface is a part of area 30. Now R4 is a part of area 0. So R4 is a part of area 0 and other interfaces are the part of other areas. So this router is called what? ABR. So in OSPF, we have ABR router concept, area border router. We have one more type of router in OSPF concept. This is called ASBR router. We have one more type of router. It's called ASBR, Autonomous System Border Router. What is ASBR router? So ASBR router, one interface, ASBR router, one interface is a part of any other routing protocol. For example, this interface, you are advertising in RIP protocol, or maybe EIGRP protocol, or maybe BGP protocol. So this router one interface is a part of area any other routing protocol, and one interface is a part of any area, area
Any
20, 30, 40, 50, any area. So this router is called ASPR router, Autonomous System Border Router. Clear my point? Clear this point?
that is clear.
Okay. Now let's talk about within an area now. Juvency. Let's talk about within an area. So I'm talking about this area, for example, area 30. Same concept you can use, same story you can use for area 20, area 0, area 40, or for any area. Let's talk about in area. So into this area 30, one router will act as a DR router. This is called DR router, and here we have BDR router. So in every area, we have two type of routers: DR router, designated router, and BDR, backup designated router. For example, within an area, if you have 50 routers, for example, 50 routers. So one router will act as a DR, one router. One router will act as a BDR, backup designated router, and rest 48 routers, they are acting as a DR other router. They are called what? DR other. Clear my point?
Yeah.
So into this area, one router will elect as a wait. One router will elect as a DR, and one router will elect as a BDR, and rest routers are called DR other. DR other. Now, what is the benefit of DR and BDR in every area? In every area, we have DR BDR concept. What is the benefit of DR and BDR in every area? So now this time, if anything happen into this area, any network down or new network introduced, if anything happen into this area, they will send the update only to DR router. They will send update only to DR router. They will only disturb to DR router. This update will not disturb to each router within an area. If you have DR router in your area, then if anything happen, all the update will only disturb to DR router, like a commander router. Clear my point?
Yes.
Any update will send to the DR router. Now DR will send this update. DR will send this update to the rest of the router. For example, some network is down here. This update will send to the DR, and now DR will send this update to the each router. So this is the benefit
Okay.
of DR. Anything happen into this area, they will not disturb to any other router. No. They will send update only to DR. Now then DR will send this update to the rest of the routers. I hope this point is clear for you. You can see.
Yeah, it's clear. That means the gear should be connected to ABR
ABR
or
router.
not. Yeah. The
See,
gear router
ABR router.
should be
Yes, ABR router is a part of area 30 and ABR router is a part of area 0. You can use your
ABR, yes.
ABR router as a DR, no problem. You can use any router as a DR.
Oh, okay.
See,
Okay.
ABR is a separate concept. DR, BDR is a separate concept. What is ABR means? This router is a ABR. Why? Because his one interface is a part of area 0 and other interfaces, they are the part of any other area. These type of routers are called ABR router, area border router. Clear my point?
Yes.
Now I'm talking about within an area. I'm talking about within an area. Now within an area, we have two type of routers, DR and BDR, designated router and backup designated router. Here the benefit of DR and BDR in an area. What is the benefit of DR and BDR in an area? Juvency? What is the benefit?
Sorry, come again.
What is the benefit of DR BDR in an area? I told you. What is the benefit? If anything happen,
For deer,
huh?
yes, yes. For deer, if anything happen in the area, all routers part of that area will send
They will send update to the
message
DR router only, right?
to the deer.
Then
Yes,
DR will send this update to the rest of the router. I hope this point is clear.
yes, it's clear.
Now let's talk about DR BDR election process. DR BDR election process within an area.
But
How they will decide?
sorry, what about BDR? What
It's a backup.
rule?
It's just a backup.
The backup. Okay,
Yes,
backup.
just
In
a
the
backup.
case of DR is not available.
Yes, DR
They will
goes
send.
down, then BDR will elect as a DR router. Okay, BDR will elect as a DR. Clear now?
Yeah.
It's just a backup router.
Okay.
Now let's talk about DR BDR election process. Okay, within an area, how they will decide? They will decide which router will act as a DR or which one will act as a BDR. How they will decide? DR BDR, DR BDR. So here we have priority value. Here we have priority value concept. All OSPF router or Cisco router has a OSPF priority. All Cisco router has a OSPF priority value, and the default priority value is 1 for all Cisco router. Default OSPF priority value is 1. And a router is having higher priority value will become DR router. For example, on this router, I'm using priority value 150. Yes, we can change. Default is 1, but we can change. We can change in between 0 to 255. Okay, so here we have 150. Here, for example, we have 140. So this router is acting as a DR. This router is acting as a PDR. And the rest router is called what? DR other.
Other.
What? DR other.
I don't get this point very well.
Okay,
This
no
is
problem.
this is
No problem. I'm telling you
from
again, no
0
problem.
to from 0 to 255 is the priority, right? You are talking about
Priority value
priority
is from 0 to
from
255.
okay.
Default is
1.
for all Cisco router. OSPF priority value is 1. Okay.
1. Okay.
And a router is having higher priority value. Higher priority value will become DR router. Higher priority
Okay.
value will become DR router. So for example, on this router, I'm using 150 priority value. So this router is what? DR.
DR.
Okay, here we have 140. So this router is what? BDR.
BDR.
Backup designated router. And rest of the routers, they are called DR other. Okay, DR other.
Yes.
These routers are called what? DR other. Clear now this point?
Yes.
How they
Clear.
will decide DR and BDR election? Okay, now let's do a basic lab, okay, for OSPF DR BDR election. Okay, give me 1 minute. I'm creating a design. I want to show you DR and BDR election process. Wait. So these routers I'm using in an area 0. I'm using in an area 0. I'm trying to advertise in area 0. IP address I'm using 192.168.10.1/24. This one is 10.2/24. Here we have 10.3/24, 10.4/24. Now let's configure IP address. Let's configure IP address here. So this is R1. Let me give a host name so that you can identify we are working with R1. As per design, I'm trying to configure IP address. Hear my point? You can see
Yes.
192.168, 10.1, 255, 255, no shutdown.
Yeah.
No shutdown. Let's go to R2 router. Host name R2. Interface gigabit Ethernet 0/0 192.168 10.2 mask. No shutdown. R3. Interface gigabit Ethernet 0/0 192.168 10.3 mask. No shutdown. Router OSPF process ID 192.168 10.0. I'm not using OSPF protocol right now. Let's configure IP address only. Let's go to R4. And I'm trying to configure IP address on here. So host name R4, interface gigabit Ethernet 0/0 192.168.10.4 mask, no shutdown. Now router OSPF process ID network 192.168.10.0 wildcard mask area 0. Let's advertise all the routers in OSPF 192.168.10.0 wildcard mask area 0. Let's go to this router OSPF process ID network 192.168.10.0 wildcard mask area 0. So I'm trying to advertise all the devices, all the routers in OSPF area 0. 10.0 wildcard mask area 0. Any problem in root advertisement? UNC?
No, it's okay. It's okay.
Okay, now. So let's go here. Let's go for verification. Show IP OSPF neighbor. Please wait. It's taking time. Now you can type show IP OSPF neighbor command. Let's see. To verify DR and PDR information. So you can see we are here, right? You can see this is R1 router.
Yes.
We
Yes.
are here. So this is R1. This is R2, R3, and R4. So you can see as per our output, show IP OSPF neighbor. As per our output, 10.4 neighbor status is what?
Yeah. Ah, okay.
10.3 is what?
BTR.
And 10.2 is what? DR other.
BTR other. The
Now,
other.
now you can see, you can verify priority value here. Now you can verify priority value here. Here we have default priority value on each router. Default priority value on each router, and default priority value is 1, right?
1, yeah.
Value is 1. So if there is a tie, in between priority value, the tiebreaker is higher router ID. Remember in OSPF, we have router ID concept. Router ID, if you forget, no problem, we will discuss, okay? Router ID. But here we have higher router ID. Higher router ID on R4, 10.4. That's why this router by default, this router is acting as a DR. Clear my point?
Yeah. Yeah.
Our discussion right now is on priority concept. So here we have right now this R4 is a DR, this one is a PDR, this one is DR other, and this R1 is also a DR other. Now, in case if I want to use R1 as a DR,
Okay.
if you go and verify on R4, for example, show IP OSPF neighbor. So you can see R1 is what? DR other. R2 is what? DR other. R3 is what? BDR, right? In case if I want to use R1 as a DR, R2 as a BDR, then we need to change priority value here. Okay? We need to change priority value here. Let's go to R1 router and how to change priority value. So you can go to interface. Gigabit Ethernet 0/0. And what is command? IP OSPF priority value. IP OSPF priority value. And if you type question mark, you can see you can select a number in between 0 to 255.
255.
So I'm using, for example, I'm using 150, 150, 150, and now I'm trying to restart OSPF process. So command you can use clear IP OSPF process. Yes. I will press enter later. Okay. Let's go to R2 first. You can go to interface, IP OSPF, priority value. And a priority value I'm using what? 120. Here I'm using
150,
150 and here I'm using 120.
120.
Now, clear IP OSPF process. I'm not restarting this router. I'm trying to restart only OSPF process. Now let's go to R3. Clear IP OSPF process. Let's go to R4. Clear IP OSPF process. Okay, let's start. Okay, now wait. Wait, they will take time. Now, as per our task, we are using 150 priority value here. 150 priority value here we are using 120 priority value. So now if you verify again this time, on R4 router this time, so you can see show IP OSPF read. So as per our theoretical portion, on R1 we
Okay.
have higher priority value. So this router is what now?
Yeah.
And R2 on R2 we have priority value 120. So status is what? BDR.
Media. Okay.
Clear this point? DR, BDR election process.
Very clear.
Now, let's go to this design. Let's go to this design. Okay. Now, into this area, for example, one router is a DR, one router is a BDR, right?
Media. Yes.
BDR. Now you can, for example, into this design, you have, for example, these two routers. These two routers are low-end router, for example. Into this area, you have some low-end routers, you have some mid-range router, you have some high-end appliance within an area. For example, these two routers, for example, this is R5 and R6. These two routers are low-end router. For example, you have Cisco 1841 series of routers. Entry-level routers, for example. You have limited hardware resources here in R5 and R6. And you don't want to, for example, R5 and R6, they have limited hardware resources. Limited hardware resources. So if you want, whenever negotiation happen for DR and BDR, whenever negotiation happen for DR and BDR election, these two routers, they will not participate in DR and BDR election process. Clear my point? You can see
Yes,
that.
because of limitation of resource.
Yes, they have limited hardware, okay? They cannot handle
Okay.
too much load.
Yeah.
They cannot handle too much load. So that's why I don't want to use R5 and R6 to become DR and BDR. No. Okay, because when DR goes down, BDR will become DR and the next router will become BDR.
Yeah. Okay.
So my point is what, whenever negotiation happen, I don't want to use R5 and R6 as a DR or
Yeah,
BDR
and B.
process.
Mm.
Okay, so you can verify here. You can verify into this design. For example, let's go to R2. Or let's go, sorry, gigabit Ethernet. Okay, let's go with the R4. Okay, no problem. R4. So interface gigabit Ethernet 0/0. IP OSPF priorities. Now clear IP OSPF. I'm using default priority value on each router. Okay, let's go with the default priority value again. 0/0 IP OSPF priority value 1. Clear IP OSPF priority. I'm using default priority value on each router. Show IP OSPF priority 1. Clear IP OSPF process. Clear IP OSPF. Now, so I'm using default priority value on each router. So if there is a tie, if you remember, if there is a tie, a router is having higher router ID will become DR. Remember our uh,
Yes.
previous task where we have same priority value on each router. Then this R4 on R4 we have higher router ID, so R4 become DR. Remember our discussion?
Yes.
We are using up now. This time we are using same priority value. Here we have priority value 1, priority value 1, priority value 1, but on R4 we have priority value 0. So this R4 will not participate in DR BDR election.
Okay.
Yes, let's verify. Let's verify. Show IP OSPF neighbor. You can see R4. R2 is a wait. We change priority value on R2. Okay, it's a different interface. Wait, give me 2 minutes. Okay, let's go to R1 now. And we can start our verification. Please wait. This will take time. Show IP OSPF neighbor. So you can see now we have same priority value on each router. But R4 is not a
R4.
DR. Why? R4 is what? Why? Because we
B
have priority value.
DR order. It's 0. It's lower.
This route will not participate. This router will not participate in DR BDR election process. Clear this theoretical portion in practical?
Yes, it's very clear.
Okay, Juvency. Now
Yes,
let's
it's clear.
continue this point. Let's continue this point tomorrow. Okay, same time.
Yes.
Clear? Bye. Take care.
Thank you. I have one concern. I didn't receive the video of last session,
Okay.
last 2 sessions.
I'm sharing both the recording 30 minutes. Okay.
Yes, and also I have one issue with my Genius tree. I don't know. I lost everything. Event router. I'm not. I'm not showing my router. Can I share the screen and
Yes, sure.
can check? 2 minutes.
You can share your screen.
Nice.
You can share your screen now.
Okay. Because I did also some practice. Where is this? Where is this Genius tree? Is it open? I can share all my screen. Okay. This one is Zoom. Let's go to, okay. Here, this one is the VMware.
Yes, now you can
The
start
problem is,
GNS3.
yeah, it started from here.
Yeah.
You
Can you
see, when I come here,
Mhm.
no router.
Can you please allow remote control request?
Okay.
What IP subnet you are using? Can you cancel this? Can you cancel this? Okay, wait. Close this application. Let's go to, can you open VMware workstation now? You can see.
Yeah, it's open.
VMware workstation, yes. Right click on GNS3, right click on lab, right click, go to setting.
Setting.
Yes.
Okay. Okay.
Wait. VMmate 1, VMmate 8. It's good. Click on cancel. Okay, 192.168.59. Okay. Start your GNS3 software again. Wait.
Because I did some lab of static root, and when I find this one was not working, I download the packet tracer, and I did it. Okay, can wait. Okay. Is
Now please
this
allow remote
subnet?
control request. Okay, wait. It's not showing here. LAN card is not showing. You can power off your GNS3, okay? Restart
Okay.
your laptop and enable and disable both the LAN cards. Can you click on cancel?
Okay.
Can you click on close this application?
Yeah. Yes.
Yes. Now, can you open? Wait, let me do this. So I think you don't have IP address on LAN card. Okay, see, you are getting IP
Okay.
address from Apipa. So what is the troubleshooting? You can just go to LAN card setting ncpa.cpl. Whenever you face this issue, ncpa.cpl. You can disable and enable both the LAN cards. Just disable, okay? Disable and enable
Okay.
whenever you face this issue. Now it will work, okay? You can close this GNS3 VMware GNS3 software. Close this and you can start again. Now it will solve, okay? You can try to and see.
Okay.
Now restart your
Let's.
power off first, VMware workstation, GNS3 VMware workstation. Or maybe
I need to power off my computer, right?
can you minimize this? Can you minimize this?
The CMD.
Minimize this command prompt and wait. See.
Um.
Click on OK. Click on OK.
Sorry. Should be.
Now it will work. Can you click on router?
Ah,
Can you see? Let's continue
now
tomorrow.
it's okay.
Okay.
Thank you.
Bye. Take care.
Thank you.